In this video, we'll show an example of the fundamental theorem of calculus in use. So suppose we have a function f of x equals 4x minus x squared, just an upside down parabola, and we want the area that is above the x-axis, so going from x equals 0 to x equals 4. Of course, this is a nice, smooth, continuous function. So this will be the integral from 0 to 4 of 4x minus x squared dx. And the way we evaluate this is, first of all, to find the antiderivative of this function. So we find the antiderivative of each piece. The antiderivative of 4x would be 2x squared. And the antiderivative of x squared would be x to the third over 3. And then the way that we show that we're going to evaluate this at 0 and 4, we draw a vertical line, and we just show 0 at the bottom of the line, 4 at the top of the line, to indicate that we're going to plug in 4, figure out the value, plug in 0, figure out the value, and subtract them. So evaluating now, what we get is 2 times 4 squared, so that's 32, minus 4 cubed, that is 64 over 3, minus, and then plugging in, we get 0 in both places. And so this is combining the fractions. Now we have 96 over 3 minus 64 over 3 equals 32 over 3. And this number, 32 over 3, is the exact area of this function, the area under that curve from x equals 0 to x equals 4. And we found this using the fundamental theorem of calculus.